All right, so with all the pistons in, oil pan done, just doing block prep for the heads. Nothing special. I already took a razor blade and just scraped the deck surface, get any major junk off of there. Had the shop vac going next to it to keep it as much as I can from falling in there. Next thing I'm going to do is a little flat sanding. This is 400 wet dry on just a piece of metal that I had laying around. And I'm going to spray it with some penetrating oil. You can use whatever you want. And let's see here. Just kind of give it a little flat sand. Wipe that off, see what it looks like. And I'll wipe it down with some brake clean before the head gasket goes on. Alright, next thing I'm going to do is chase the threads for the head bolts. Basically have an extra long, or I'd say an extra head bolt, one of the longer ones. This is a Gen 3. I actually didn't have a spare Gen 3 bolt because I don't have spare parts around. But the only spare LS I have is an 07 that was seized up. And I took two of those head bolts, which are shorter, and welded them together and made one. And all I did was cut some grooves in the threads with a cutoff wheel and turn it into a thread chaser. So just throw it in, take it out, and you can see some junk on the threads there just from getting it through that. So blow it off, go to the next one. And I'm just going to run through all the head bolt holes, clean them up. Alright, so I chased all those threads. They're all cleaned up. Next thing I'm going to do is just blow them out with the air gun. Alright. The reason I'm so concerned about the head bolt holes is, unlike a small block Chevy or a big block Chevy, these head bolt holes are blind holes. So if you get any fluid in there and don't get it out, you can hydrolock this, actually thread the bolt in, compress the fluid, and crack the block. So you don't want to do that. And you don't want any junk in the threads, because that'll affect you when you go to torque the bolts. Alright, last thing I'm going to do is put the dowels back in the head. Back in the block. Go. And that's pretty much it for the block until it's time to put the head on. So now I'll move over to the cylinder head. My limited workspace is getting even more limited. This happens every time I build a car. Stuff just starts piling up everywhere. need to spend some time cleaning up. So, with the block pretty much ready to go, next thing is the head. I hate cleaning these things. It takes a while. But I think next time I will definitely pressure wash the engine before I take it apart, because I soaked this in carb cleaner just to start getting it cleaned up. It's still pretty dirty. Anyway, you can see this side of the head is much cleaner than this side right now. I just started lightly hitting this with the razor blade, and yes, it's a metal razor blade. I'm not pushing hard enough to dig into it. This is just to get the larger amounts of glue off the head. I had put some carb cleaner on it to try to weaken it, loosen it up a little bit. But the plastic razor blade just doesn't seem to do very well. So just kind of lifting it off, and I have my shop vac here to clean it up. And normally I would just have the vacuum running while I do this, but not for the video. So you can see I'm just lightly hitting it. I'm not pushing on it or anything. I don't want to dig the razor blade into the head and put a scratch in it. I'm just trying to get the glue residue off from the old head gasket. So let me fire up my vacuum and razor blade this whole head. Alright, next thing I'm going to hit it with the 400 wet dry. Same stuff I used on the block. Just going to kind of give it a little sanding here without getting my glove hooked under it. And just work on the little residue that the razor blade didn't want to take off, because I'm not going to push on it. The razor blade is just to lift off the major stuff that was softened up with the carb cleaner. Alright, I hit that a few times with the wet dry 400. That'll be good enough for the moment. Still got to spray it with brake clean before it's finished, but I don't know if that shows on camera, but you can actually see the factory machine marks on the head when you clean it like that and sand it down. It makes it very flat. There's still some staining marks on there, but it's not anything that's raised. You know, I think that's just imprinted into the aluminum. There's probably no way to get rid of that without shaving the head, which we're not going to do. So that's the first basic cleaning. As I said, the head still needs a good spray down with carb cleaner. But before I do that, or brake clean I'll use probably, but before I do that, I got to change these valve springs. I got to put in the, I got packed the usual pack 1218s, which seem to be very popular for these swaps. So, got to swap out the springs before I finally clean the heads and install. So that'll be next. Alright, I lied. I sprayed some brake clean in here to clean this up a little bit, because it was too dirty to even just to pull the springs out. I didn't want to work on it this dirty, so I gave it a quick spray down. It'll need another one, but next thing I'm going to do is change the springs. Now, there's multiple types of spring compressors out there. This is what I bought. I bought this probably a year ago when I was first starting this project and didn't know much about LSs, but this is what I bought. And all it is one-piece unit, a stud, and a nut. And after I just opened this up yesterday for the first time since I bought it, and after looking at it, I was kind of skeptical. I was like, is this really decent? In fact, to the point where I went online and bought one of the units that bolts in and presses both springs down at once, so you can do two. But I was like, you know what? I'm going to try this because I need to get this project moving, because I have another car that is on the list and needs to be I got to start working on for my own commitments, and I will talk about that later. But so I tried this yesterday, and as cheesy as this thing is, it works. So all there is this stud, and all I'm going to do is put a little grease on each piece of hardware to keep stuff from galling up, and I'll show you how it works. All right, so first thing I have is this stud. Just going to put a little bit of grease on it. Not much, because the holes in the cylinder head, I think they're blind as well. You put too much on this, or hydrolock or so say, and you can crack your head if you had oil behind it or something, or too much. So just going to thread that in by hand. I'm just lubing it so I don't screw it up. Next thing's this piece. Now this thing here, I think it was designed so that the machined recess would go over the spring keeper, the top holder, top plate, whatever they call it, the spring retainer. But it's a little too wide, and it actually digs into the hat there. So what I'm going to do is use the flat side that's not machined. I'm just going to drop that right on there like that. I'm going to put a little grease on the stud and on the base there. And then I just have a washer. I'm going to put a little grease on the washer, another washer, both flat washers that come with it, a little bit of grease on them, and a nut. 14 millimeter. And the other thing, oh, I forgot. One of my concerns with this type of spring compressor is that one end sits on the head, and I didn't want to didn't want to mess up this sealing surface for the valve cover gasket. So just took an old sock and put it under it as a safety. And then I'm just going to screw this down. Let me see if there we go. So basically just compress the spring enough that I can grab the keepers with the magnet. A screwdriver to move this one over. Thing is, when the spring compresses, it goes down at a little bit of an angle, so it might hit the valve stem. So if it feels like you're compressing the spring and the valve is moving down, back the nut off, and you can reach underneath and push on the spring and get it back up. Once the keepers are out, just spin that back out. And that's it. Springs out. Works easy. Your valve seals right there if you want to replace them. I'm not replacing them on this engine because I don't know if they're good, don't know if they're bad. And it's a low buck build. If the thing smokes, whatever. I'll change the seals out. So this is my old spring. Get install my new Pack 1218. Drop it on. Drop the valve cap on. Put this guy back on. And I'm just gonna line it up so it's over the valve. I stuck a rag underneath the cylinder head. What is that? Okay, I have to show you that. Yeah, in fact, you know what? Watch this. I was just going to install this this valve, this valve spring, and I saw something inside the exhaust port. Corn kernels. Yeah. That's what you get when you deal with engines that have been sitting around in trucks that have been sitting around. Nice. Okay, let's get back to the spring install. All right. So I was saying, I'll stick a rag under the valve to keep it up. I'll put my spring in with my spring cap. This guy back on. Just kind of line it up. Oh, hang on here. Just forgot my sock. Go. All right, I'm going to compress this down. And I'm just going to compress it enough so I can put the valve keepers back in. These are the keepers. They're just wedges. There's one. Let's move it over. Next one. And that's all there is to it. Unthread the stud and move to the next one. Really doesn't take that long once you get going to do this. And for a cheap tool, it actually works. And what's nice about it is if you did somehow gall the threads up on this stud, just get some all thread and you're back in business again. You can make another one. I don't see this piece wearing out. It's plenty thick. So, does the job. Okay, all the springs are in. And I got one more thing I need to do here. And that's tap this rear port in the head for 3/8 pipe thread so I can run my temperature sensor there. So you need a 8mm Allen key or socket or whatever. I already broke this loose. It is Loctited, but I just gave it a good smack and it came out, or got loose anyway. We'll take that out. Just a plug. All right, and tools you need: 37/64 drill bit. See, I marked it when I bought it. 3/8 pipe thread tap. Got this from Harbor Freight, from a kit that comes with a 1/4, 3/8, and 1/2 inch. And I found a 16mm 12-point socket. Fits it to turn it. So, first thing, gotta drill a hole. So we'll get our brandy new drill bit out here. And I'm going to put some grease on this guy, even though I'm not drilling this in the car. I'd still like to catch the threads if I can. And here we go. If I'm straight, we will go. In fact, I'm going to get the drill, get the vacuum going. All right, and holes drilled, and I will say, even with the grease on the drill bit, a lot of shavings went into the cooling port, because when I picked the head up, I had a pile under here. So doing that on the car, that's a little dicey. That's got to be a little difficult to get the shavings all on the drill bit and not falling into your cooling system. All right, same thing here. I'm gonna grease up this tap to lube it and to also catch some of the shavings. And once this gets started, it'll be pretty easy because it's aluminum, but I'm not gonna tap it in very deep, just enough that my fitting will thread in, because the threads have to make the seal. NPT, it's National Pipe Taper, and the tapered threads actually make the seal, so if you drill this or tap this out too far, you'll make the hole too big and it won't seal up. So I'm only going to go in a little at a time and keep checking with my fitting and see what it looks like. Now, unfortunately, my gloves are covered with grease. Wipe them off. And we'll see if we can get this started. I can see it is cutting threads, which is good. And hopefully I'm straight. Looks pretty good. Not even a lot of effort to cut into this, so you want to take it easy. All right, I'm going to back it out now. When you're cutting threads, you don't want to just jam it in there. You want to work it back and forth to get the junk out. You can see with my fitting here. All right, I got a 3/8 temperature sensor here to thread in. It's just out of some old car, whatever, just as a test, and that's good. Goes in a few turns and then stops. So I put a wrench on it and it'll tighten up nicely. All right, good. We're just about done with this cylinder head. All right, so now that the cylinder head is cleaned off over there on the bench and the deck is cleaned, both surfaces I wiped down with some brake clean and just blew them off with the air gun. I have my head bolts here. I just blew those off with the air gun as well. Just make sure there's nothing in the threads. And we'll get this head on here. Let's Been a busy day already, trying to get stuff done. Already been on the road for quite a while for that there piece of junk. That'll be discussed later. Alrighty, so look at what we got here. I chickened out. I was going to reuse the original head gaskets, but they just didn't look like they would be a good usable thing. So LS9 head gaskets are usually what people use, which are 7-layer MLS. Well, Brian Tooley Racing now has 7-layer MLS small bore. So these are actually made for the smaller 4/8 and 5/3s. So this is what I'm going to use. No copper spray needed. I'm just going to blow them off and go with these. All right, these are not labeled front or back, but the rear part of the gasket will always have these extra 2 cooling holes, so those are going to go toward the rear. Just like that. Pretty thick head gasket. They fit nicely right around the bore for these smaller engines. All right, set the head on there. That. All right, head is set on there. Just gonna take each head bolt. I have some clean engine oil here. I'm just gonna dab the end of the bolt in the oil, not much, just a little bit. It's got a little bit of lube. I'm just going to spin them down. Not torquing anything yet. All right, all 10 bolts are just spun in. Now it's time to torque them down. All right, time to torque these down. I'm going to start with my clicker, 22 inch-pounds. And I imagine I'll have to do this a few times. Let everything seat. I know the torque pattern, so I'm just moving right along with it. I'm going to do this a few times, as you can see how as things compress, they over here, I'm talking and doing the same time, they loosen back up again. So until they stop moving, I'm going to keep going over them. See how many times it takes. Okay. I think that's good, but I'm going to do it one more time anyway. And I'm not doing anything with the top 10mm bolts. I haven't even put those in yet. I'm going to do this again for 22. A little bit of movement there. All right, so 22 is done. Now it's time to move to the angle. All right, so next thing is going to be angle. I know the sloppy way I've seen is just go to 65 foot-pounds, and that's fine if you want to do that. I'm going to do the angle method, and I don't know if this will show me the torque it's at, but I'm reusing head bolts, and I'm just going to follow the regular procedure just because I don't have enough experience to know what's what, even though they say it works. All right, so I've got this set right now for 90 degrees. So here we go. Should make it foolproof. Got to reset it after each bolt. It makes it pretty much idiot proof. So even I can do it. Right. All right, now I'm going to go another 90 on the first 8 bolts, but not the last 2, which are a little shorter. Those are only going to go to 50 degrees. So here we go, another 90. One. Two. Three. Eight. Now, the last 2 are only going to 50 degrees. So I got to change my setting here for 50. And we'll do the last 2. And that's that. Now for fun, we could set this to 65 foot-pounds, which is what I have it set to right now, and go back over the torque sequence and just see, are they torqued to 65 right now? What I'm going to do is use a paint marker and mark these bolts. Go to 65 foot-pounds and see if they move. Now, I'm not going to go nuts here because I don't want to break a bolt, but I'm just going to go to 65 and see. Yeah, that's at least 65. And 65. 65, 65, 65, even the short ones, I'll check them. Yeah, even the short ones are at least 65. Now, looking at my marks, This one looks like it moved a hair. None of the others moved at all. But what's weird feeling about these stretch head bolts, which is different than what I'm used to, is they feel like they're turning when they're not, but they're actually twisting. So I can see how people break these things off when they overdo it. Because, you know, small block, big block Chevys that I'm used to working on, you torque a bolt, it's torqued. And then when you go to tighten it, it doesn't move anymore. That's just the way it is. But these actually have twists to them. You can feel it. So I can see how people have broken these off just going to a torque spec. So I'm glad I bought this, and I'll stick with doing the angle method. And yeah. So head is on. Continue on. All right, next thing is going to be push rods, but I'll just dump some oil on these springs and a little on these push rods here, using up a little bit of leftover clean oil that never got used. Okay. All right, so I cleaned out the holes. I got 8 good push rods in there. If you remember during the teardown, I had 2 bad push rods that have like a football type wear pattern. You see that? That's no good. It's actually pretty common. And also what it does is it wears out the inside of the rocker arm as well. If you compare that to a good one, that worn area is much larger than on one that's good. Right, here are my rocker arms. Just set those there. You get a socket, spin those down. All right, here's my rocker arms. All right, these have to get torqued to 22 foot-pounds. And of course, the first one I hit, it was on a spring, so I'm going to leave it alone. Come back to it. And that one's on a spring. I think that has some tension on it as well. The engine over some. Now, one thing I didn't do here is I did not check push rod length. So, again, I'm used to small block, big block Chevys with adjustable valve trains. This is not adjustable. You torque these rockers down and you're done. Now, what I see here is instead of having 0 latch and a little preload, some of the rockers have a ton of slop. Now, I'm just attributing that to the fact that there's no oil in the system and the lifters are not pumped up. So I will double check that after the system's got oil pressurized in there, and once the lifters are pumped up, we'll see if that goes away, because you shouldn't have any slop between the spring and the rocker arm there. That's not good. At least that's not good if that's what looks like the final result. If that's the case, then I think I'm going to need longer push rods to put this down a little bit more. And I'll find that out once I get oil in the system. And of course, now that the rocker arms are on, I remember about these guys. The afterthought, I don't know if they're not really head bolts. I guess they're just kind of there. I mean, even GM doesn't seem to even want you to mess with them until later, so you just shoot those down. And those go to 22. And that's it for those. And of course, I got to double check them, even though they probably don't matter. All right, that's done. All right, that is it for now. I think the only thing left to do is prime the oil system. I'm going to try to make an oil primer thing and prime this. I just threw valve covers on for now, just to keep anything out of it, and I'll cover it up. I'm running 2 driver's side valve covers, so I can use the screw-in fittings to go to AN10 hoses for the catch can. Again, another turbo thing that would not normally be done. But I think it's just about time to set this back in the car. Of course, I got to put the transmission on first. But yeah, it's moving along. See you on the next one.